very last topic for this class, section 4.6, we are going to review not anything, not any new calculus in this section. There's just a lot of kind of algebra. So this is basically a review on exponential models and how to find them. So we have a thing called the law of exponential growth and decay, which says that if you have a quantity whose rate of change over time is proportional to the quantity present at any time t, then a formula for the amount of thing that you're looking for, the quantity y, is exponential in its form. So in other words, you can write it as y equals ce to the kt. Now, I talked with you a little bit about this when we were talking about exponential functions, but just to give you a sense of what this means. So if y is a quantity whose rate of change over time is proportional to the quantity present at any time t, what that really means is that the rate of change of y, dy dt, is proportional to y, the amount present. Proportional means that you have some constant times the other thing. So the rate of change of y here is proportional to y, means that the rate of change equals some constant times y. Now, if you just don't think about the letters too much right now, but this is saying the rate of change of something is this function itself times some number maybe. And the only function that we know of whose derivative is itself, right? Derivative of y is y times some number, is an exponential function. Okay, so that's why we have this solution to this equation here. This is called the differential equation, something that relates something and its derivative. Anyway, it is an exponential function. So each of these things have a couple, some meanings here. So the y is the output variable. It normally will represent a quantity remaining of something. The t is the input variable. And this is usually time, but it doesn't have to be, but often it's time. The k has a particular name. So this is called the growth or decay constant. So if you have a positive value for k, you have growth. And if you have a negative value for k, then you have a decay function. And then the c here, just like we talked about with exponential functions in general, this is the initial value. So this is what you get when you plug a 0 in for t. Okay, so in the rest of the section, we're going to look at how to basically build exponential models based on some data points. And so I've got, I think, two or three examples that we'll look at with that.